So in this third step, I'm going to describe why this third step is similar to DFS. And in fact, the third step can be done by all the graph transversal algorithm. DFS is just one of the things that we have seen previously. You can do something like a BFS, DFS, but it is the same. So the situation is like this. We have the epsilon and the mean samples given. Right? And so if we pick one vertex called the X and make an epsilon ball, the radius is epsilon, and now it has enough vertices nearby, so X is a core. In this case, we are going to switch the data, at least in our mind. Okay, in our mind, we are going to transform the data into a graph. But you may or may not heard of this structure, but it is just something with some points, and this is representing X, and each points represent one data. And then I'm going to draw an arrow. If X is a core, and it is going to draw the arrow outside to all of its neighbors. So the philosophy we mentioned before is basically saying if I have a vertex X and it is a core, it has an arrow goes to Y, then label of Y is assigned by the label of X. And you will keep promoting this information or propagating this information, 传递这个讯息, okay? Propagating this information throughout the graph. And here is an example. So this is a simplified version of the data we have seen before. Imagine that this is some data set, and maybe there are some noise. Okay, and then each of the point, you can draw a circle and then determine whether it is a core or not. If it is a core, then you are going to draw some arrow from this point to its neighbors. So this means this particular point, it is a core. And let's say this is also a core, just an example. So you will come back and draw to here. And then this is also a core, so it draw to all the points nearby, has an arrow goes to nearby. So you can tell that this arrows looks like this is a cluster. By cluster, I mean it just looks like that. And these 3 points has double directed arrows going between them. So this one and this one has the same index. This one and this one have the same index, same index, same index. Okay. And now let's try to finish all the arrows. If you look at this one, and maybe I say it is not a core, so this one has no arrows coming out of that. It just stop here. And this one is even worse. It is not a core. And say maybe here it is a core. These 3 points has the same behavior as the one on the left. And this one is a core. It has a neighbor to the right. So once we have this understanding, the remaining problem is try to find out how many territories on this graph. By territory just means that, okay, I pick this one is a core, and it is a core, and it is not labeled. So I'm going to label that by 0. And following the philosophy, because this is 0 and this is not yet labeled, and I have an arrow going there, so I'm going to label that by 0, label this guy by 0, label this guy by 0, and label this guy by 0. And this part is done by the DFS we have just seen previously. And later on, because all these parts are done, so 0 are done, there's no more points that belong to the cluster 0. Now I found another core which is not yet labeled. I'm going to label that by 1. This is a new label. I'm going to start a new territory. So this new territory will go to here, and go to here, and go to here. And we're done. And so the last one, I did not touch anything about that, and this one is going to be a noise. So if you focus on this particular case, then you will realize that only the red points are the cores. And some of encore samples, they will still be labeled, like this one, and this one, and this one. But some of the encore samples will not be labeled, and they will just be the noise. So that's a situation happening in step 3. So I know by knowing this idea is not too bad, but if you want to transform this idea into the code, it still takes some time. So here are something that I can help. Of course, if you like some challenge, feel free to do it by yourself. Okay, and here is what I'm going to do. I'm going to copy that to here and try to explain that hopefully line by line. Okay, so the first line is quite straightforward. Y new is the label that we are going to do, and we are going to assign that as np.ones, but with a minus sign in the front. So this is assigning each vertex, each point by -1, and which means that it looks like everyone is unlabeled. -1 means unlabeled. And then I'm going to start with label number 0, and then I'm going to go through a lot of points and try to label territory 1, territory 0, territory 1, territory 2, and in the end, if there are still some point that is unlabeled, then they are the noise. So I'm going to go through all the vertices, all the data point, and I do the following only if this point is unlabeled and also it is part of the core. So this line means xi is unlabeled and it is a core. So I run through all the things. If it is an unlabeled core, then I'm going to do the following. And this step is actually the DFS. So I'm going to add 1 into this, we call that stack. Stack is like you have a stack of papers and you have to read the first one, read the second one, but sometimes it goes higher, just like homework. Okay, so you have the first one on the stack. This is the to-do list. Now, unless you finish all the to-do list, then you stop. Otherwise, you have to keep going. So this one, pop, means that take one out. You just take one of the tasks from the to-do list. take one outside, take one out, and remove. Pop means take outside one of the element and remove the element. So I take one of the to-do list element from the to-do list, and then I'm going to check, okay, whether it is unlabeled. If it is unlabeled, then I'm going to label that by the same number we are doing. I'm doing 0 now, then I'm going to label that by 0. And moreover, if it is a core member, then all the neighbors of the core neighbors should be added into the to-do list. So the philosophy is, at the beginning, I only have one point. But if I go outside, go to J, and J has some neighbors, and all these neighbors, if it is a core, all these neighbors has to be added to the to-do list. And later on, I am going to go through the to-do list again and to check if I need to go further and to label more vertices. And so that's kind of the process of the depth first search. You will keep going until nothing can be done and come back. And if in the end there's nothing can be done and stack is empty, which means you have finished all the things on the to-do list, then you finished. And once you finish this part, it means that you colored or you labeled the category, the territory by the label number, and then you should increase the label number by 1 and initiate the next process. So I will leave this on the screen, and hopefully that can help you a bit more. And so, just a reminder, see Cyber University for more information. About DFS, okay. But that's really not the core part of this this course. If you feel like it is just too bothersome, and try to just have a big picture of that, unless you are doing the homework for this group.